calculate the amount of reactants or products in a chemical reaction. Also, I'll be talking about a limiting reagent and reaction yield. I'll provide a link in the description of the video for the website where you can download the material and watch the video. First, the amount of reactants and the products for any chemical reactions that happen between such A and B to give me C. I have to have a certain amount of A to react with B to give me C. This is what we call stoichiometry, and the stoichiometry study is actually the study of how much, or the quantitative study of the reactants and the products in a chemical reaction. If I know the amount of A, I can find out the amount that can react with B or the product that obtained from this chemical reaction. But first, we need to write a balanced chemical equation. Second, you have to convert all amount of the reactants to mole. The third, you can use this mole ratio of the balanced chemical equation to calculate the moles of the products. You need to convert after that the moles of the product into grams. So, like we see here in a scheme, in the scheme down, you have amount of A. First, amount of grams of A. First, you need to convert it into moles. After you convert it into moles, you can find out from the balanced chemical equation the ratio that A reacts with B. Then you can find out the moles of product B, and from knowing the moles of the moles of B, you can find out the grams of B that reacted with A. You can also further calculate the moles of product, and from the moles of product you can find out the grams of product that reacted with obtained from this chemical reaction. Let's take one example. What is the amount of ammonia in grams produced when nitrogen reacts with hydrogen? So if I started my reaction with 16 grams of hydrogen that completely reacted with nitrogen, how much ammonia do I have? Like we see here, the chemical equation, nitrogen reacts with hydrogen to give me ammonia. So first thing, I have to balance my chemical equation. So N2 plus H2 to give me NH3. This means I have here 2 nitrogens that react with 2 hydrogens to give me 1 nitrogen and 3 hydrogens. So if I multiplied these hydrogens by 3 and multiplied this ammonia by 2, let's see, N2 plus 3 hydrogens to give me 2 NH3. Now let's count the number of atoms. So I have here 2 nitrogens, and I multiply the 2 by 3, which is 6 hydrogens, and this part I have 2 nitrogens, and I have to multiply also the 2 by 3 to give me 6 hydrogens. So this is my final balanced chemical equation. So from that, if I have here 16 grams of hydrogens, how much ammonia are produced in this chemical reaction? To be able to do that, I have first to convert my grams of hydrogens into moles, and from moles of hydrogen I have to convert it into to find out the ratio between the ammonia and hydrogen, to find out the moles of ammonia, and from the moles of ammonia I can find out grams of ammonia that are produced. So I can do this calculation in one step. So grams of ammonia would be equal, first the grams I'm given, 16 grams of hydrogen, multiplied by, if each 1 mole of hydrogen is equal to 2 grams of hydrogen, multiplied by, now I need to convert to find out the ratio between the ammonia and hydrogen. So I want to find out the ammonia, so I write here number of moles of ammonia, which is 2 moles. So 2 moles of ammonia, and the moles of hydrogen is 3 moles. So I divide here by the 3 moles of hydrogen, and then I need to convert my moles of ammonia into grams. So I have for molar mass of ammonia is equal to 14 for the nitrogen plus 3 hydrogens, each is equal 1, so the sum of that is 17 grams. So each 17 grams is equivalent of ammonia is equivalent to 1 mole. So if I calculated this ratio, this means I have 19 grams of ammonia. Another example. Here we could see that the degradation or the breaking down of glucose in presence of oxygen in human body, it gives carbon dioxide and water. If I started with 856 grams of glucose, how much carbon dioxide is produced? To know, first I have to look at this chemical equation. I could see that it is already balanced. I have 1 mole of glucose reacts with 6 moles of oxygen to give me 6 moles of carbon dioxide and 6 moles of water. So I can start by knowing the molar mass of glucose. The molar mass of glucose is equal to 6 carbons, which is 12 for each one of them, and 12 hydrogens, 12 multiplied by 1 grams for each, and 6 in oxygen multiplied by 16 to give me 180 grams. So each mole of glucose is equivalent to 180 grams. So if I want to know the grams of carbon dioxide produced, this means it will be equal to the number of grams that enter the reaction, which is 856 grams glucose, multiplied by, for each mole it contains 180 grams of glucose, then I need to convert this moles of glucose into moles of carbon dioxide, knowing that I get 6 carbon dioxide, 6 moles carbon dioxide, equivalent to 1 to each 1 mole glucose. And final step will be converting the moles of carbon dioxide into grams. So the molar mass of carbon dioxide is equivalent to 12 for the carbon plus 2 multiplied by 16 for each oxygen, which is equal to 44 grams. So I will write here the 44 grams of carbon dioxide for each mole of carbon dioxide. The answer to that is equal to 1.25 multiplied by 10 to the power 3 grams carbon dioxide. Now let's look at another example. Here we have lithium reacts with water to give me lithium hydroxide and hydrogen. Now if I know the grams of hydrogen that are produced in this chemical reaction, what is how many grams of lithium are needed to produce this amount of hydrogen? So I will need to convert the grams of hydrogen into moles of hydrogen, and from moles of hydrogen ratio against the lithium, I can know the lithium moles equivalent to this moles of hydrogen, and from lithium moles I can know the grams of lithium reacted. So grams of lithium would be equal to 9.89 grams of hydrogen, multiplied by each 1 mole of hydrogen contains 2 grams of hydrogen, and I have to convert the moles of hydrogen to I have to convert it to know the ratio between the lithium and the hydrogen. So I have here 1 mole of hydrogen reacts 2 moles of lithium reacts to give me 1 mole of hydrogen. So 2 lithium moles to give me 1 mole hydrogen. Then I need to convert the lithium into grams. So from the periodic table I could see that 6.9 lithium grams of lithium are present in 1 mole of lithium. This number I get it from the periodic table. This is the atomic number of lithium. So if I calculated this one on the calculator, this means I have 68.1 grams of lithium. This means the 68.1 grams of lithium would react to give me the 9.89 grams of hydrogen. Now let's move to another thing, the limiting reagent. Like we said before, if I have A plus B to give me C, I have to have a certain amount of A to react with B to give me C. Sometimes when I react A with B to give me C, one of those components, A or B, is so expensive. So I present the other which is less expensive. If A is so expensive and B is less expensive, I present B in an excess amount to make sure that all the amount of A are converted into are reacted with B to give me C. So if I have something like hydrogen plus oxygen to give me water, I could see that hydrogen is more expensive than oxygen. So if I try to react hydrogen with oxygen to give me water, usually I present oxygen in a in an excess amount to make sure that all the amount of hydrogen reacted with oxygen to give me water. So my limiting reagent in that case would be the hydrogen. So my reaction, the produced amount of this reaction, which is water, depends on how much amount of hydrogen present in this chemical reaction. Let's take an example. Synthesis of methanol by reacting 4 moles of carbon monoxide and 6 moles of hydrogen to give me this methanol. I need to know which one of them is the limiting reagent. Now I have already all my units in moles, so I don't have to convert anything into grams. From grams into moles, I already have my moles. So let's try first to use the number of moles of carbon monoxide and see how much amount of methanol should be produced. So I have to know to compare the ratio of moles of carbon monoxide into moles of methanol. And my second step is to compare it with the moles of hydrogen to give me moles of methanol. And the number of moles which is less than the other, this would be my limiting reagent. So first let's know the number of moles of methanol in case of carbon monoxide. That would be equal to, so I started if I started with 4 moles of carbon monoxide, so I have 4 moles of carbon monoxide. If to give me 1 mole methanol for each 1 mole of carbon monoxide, that would be equal to 4 moles methanol. Second step, now I need to also obtain the number of methanol that produced when I use 6 moles of hydrogen. So moles of methanol produced when I react with carbon monoxide with hydrogen would be equal. So I have 6 moles of hydrogen. So for each 1 mole of methanol, CH3OH, I start with 2 moles of hydrogen. So this means 3 moles of methanol. So if I start with 4 moles of carbon monoxide, I end up with 4 moles of methanol, while if I started with 6 moles of hydrogen, I end up by 3 moles of methanol. This means my limiting reagent is a less number of moles that are produced, which is the hydrogen. So my hydrogen is my limiting reagent because it defines how much material are produced. Let's take another example. Urea is prepared by reacting ammonia with carbon dioxide. So I have 2 moles of ammonia react with 1 mole of carbon dioxide to give me 1 mole of urea plus water. If I started with 637 grams of ammonia reacting with 142 grams of carbon dioxide, which one of those is the limiting reagent, ammonia or carbon dioxide, and how much ammonia is formed, and how much excess reagent is left in the reaction. First, I need to know the molar mass for the 3 of them. So molar mass of ammonia would be equal to 14 plus 3 multiplied by 1 for each hydrogen, which is equal to 17 grams. Second, the molar mass of carbon dioxide is equal to 12 plus 2 multiplied by 16, which is equal to 44 grams. And the molar mass of urea is equal to, I have to multiply these 2 by the N and multiply these 2 by the H. So 2 nitrogen, 2 multiplied by 14, plus I have 2 nitrogens and I have to multiply it by 2 for each one of them is 1 gram, plus 1 carbon dioxide, 1 carbon, which is equal to 12 grams, and oxygen, which is equal to 16. This is equal to 60 grams urea. So first I need to know which one of them is my limiting reagent. So to be able to do that, I have to convert ammonia and carbon dioxide into moles, and from these moles I need to know the moles of urea is formed in each case, and the less amount of urea is formed. This means my starting material is my limiting reagent. So first, in case of ammonia, number of moles of urea formed is equal to, so if I started with 637.2 grams of ammonia, so 1 mole of ammonia is, contains 17 grams of ammonia from my molar mass here. If I know that each mole of urea is formed when I consume 2 moles of ammonia, so 1 mole urea to give me 2 moles when I consume 2 moles of ammonia, this would be equal to 18.71 moles. So this is number of moles produced in case I started with this amount of ammonia. Now let's try with carbon dioxide. So carbon dioxide in case of carbon dioxide, the number of moles of urea would be equal to, if I started with 1142 grams of carbon dioxide, each 1 mole contains 44 grams of carbon dioxide, and for each mole of urea formed, 1 mole is consumed, 1 mole carbon dioxide is consumed. This would be equal to 25.95 mole urea. So here I formed 25.95 moles, while here I formed 18.71 moles. This means my ammonia is my limiting reagent. So ammonia is the limiting reagent. Now, if this is my limiting reagent, I need to know how much ammonia is produced in that case. So I need to convert the number of moles I obtained in that case into grams. So grams of ammonia of urea would be equal, so the number of moles of urea that is formed. Now I need to convert it into grams. So for molar mass is 60. If my molar mass of urea is equal to 60 grams urea, for each mole, 1 mole of urea. So now I need to convert these moles into grams, which is equal to 1124 grams urea. Now the third part says how much excess reagent is left in this reaction. We know now, if this is my limiting reagent, if my ammonia is my limiting reagent, this means my carbon dioxide is my excess reagent. So I need to know first how much carbon dioxide should be consumed, and by comparing that with the number of grams I used from the beginning of the reaction, I can know how much excess is left. So first I need, in this part, I need to know how much, so grams of carbon dioxide should be produced if I used this amount of urea. So I need to convert the grams of urea, which is equal to 637.2 grams of urea, multiplied by, if 1 mole contains, 1 mole of urea contains 17 grams of ammonia. Now I need to convert it into each mole of 2 moles of urea is consumed against 1 mole of carbon dioxide. So 1 mole carbon dioxide is equivalent to 2 moles of ammonia. I have to multiply this now by for each 1 mole of carbon dioxide, it contains 44 grams of carbon dioxide. This means it is equal to 823.4 grams CO2. So if I subtract this number from this number, I can get the number of grams of the carbon dioxide that is left. So carbon dioxide remaining would be equal to 1142 minus the 823.49, which is equal to 319 grams. This means there is 319 grams of carbon dioxide would be left out from this chemical reaction. Now let's see the reaction yield. For any chemical reaction that occurs between A and B to give me C. Usually there is what we call the theoretical yield, the amount of A, which means the amount of A that react with B to give me C. This for a perfect condition. Usually it is hard for this to happen in real life, and what we have in actual life, we call it actual yield. Actual yield is the amount of the product is produced when A plus B is reacting. It's always have to be less than theoretical, because theoretical is for optimum conditions, while actual yield means that sometimes I start with material that is not completely pure. So if I start with materials that is not completely pure, that would affect my actual yield. The percent yield would be the proportion between the actual yield and my theoretical yield. And if the reason behind that, like I said, the impurities present in these reactants, and it's impossible to recover 100% of the product. I mean by that, if I have material which is precipitating, if this material is precipitating, sometimes when I use filter paper, I get some material left in my filter paper and I lose some of my material. So I cannot have 100% recovery of any product. Also, it is hard to achieve a perfect condition, such as pressure, temperature, and so on. So my yield usually is equal to my actual yield divided by theoretical yield multiplied by 100 to convert it into percentage. And my yield actually decide if my reaction is good or not. So sometimes if I have very low yield, like 10% or something, even below than that, this means my reaction is not efficient enough to be performed, and I have to find out another reaction for this chemical reaction. So usually we use the yield, percentage yield, to know how efficient my reaction is in commercial purposes. Now let's take an example. In industry, we react titanium tetrachloride with magnesium to give me titanium. So if I started my operation with this amount of titanium tetrachloride and this amount of magnesium, calculate the theoretical yield of titanium in grams and calculate my percentage yield if this is my actual yield. So first I need to know the molar mass of titanium tetrachloride, which is equal to titanium, the mass of one atom of titanium is equal to 47.88 plus I have 4 carbons, so 4 chlorine atoms, so each one of them, the mass of each one of them is 35.5. This would be equal to 189.7 grams. And the molar mass of magnesium would be equal to, from the periodic table I know the atomic number or the mass of one magnesium atom is equal to 24.31 grams, and the molar mass of titanium, so the mass of one titanium atom is from periodic table is equal to 47.88 grams. From that, first I need to convert the grams of titanium tetrachloride into moles of titanium, and convert the amount of magnesium, of grams of magnesium, into number of moles, and from this number of moles I compare it to the amount of titanium. Then I have to compare the number of moles obtained in both cases and know which one of them is the limiting reagent. So the titanium, number of moles of titanium, in case of this amount of titanium tetrachloride is used, I need now to convert this 3.54 multiplied by 10 to the power 7 grams of titanium into, if each 1 mole of titanium tetrachloride is equal to 189.7 grams. And for each mole of titanium, I use 1 mole of titanium tetrachloride. That would be equal to 1.87 multiplied by 10 to the power 3 mole titanium. My second step is knowing the number of moles of titanium in case I used in case of magnesium, if I use this amount of magnesium. So I have to convert this amount of magnesium, which is 1.13 grams 10 to the power 7 of magnesium, into moles of magnesium. If each mole of magnesium is equivalent to 24.31 grams of magnesium, and if I obtain 1 mole of titanium for each 2 mole of magnesium used, that would be equal to 2.3 multiplied by 10 to the power 5 mole titanium. Now if I compare this amount of titanium to that amount of titanium, I could see that my limiting reagent is titanium tetrachloride. This means if I converted the number of moles of titanium, in that case when I use this amount of titanium tetrachloride, I can know how much titanium theoretically is obtained. So the theoretical yield of titanium would be equal to, first I need to convert this amount, that amount I obtained here, 1.87 multiplied by 10 to the power 3, if each mole of titanium is actually contains 47.88 grams of titanium. This would be equal to 8.95 multiplied by 10 to the power 6 grams titanium. This means if I start with this amount of titanium tetrachloride, I obtain this amount of titanium tetrachloride. So if I need to know, so this is my theoretical yield. Now I need to know the percentage yield. So to be able to know the percentage yield, so yield would be equal to my actual yield divided by theoretical yield multiplied by 100. So my actual yield that I obtained in industry, which is 7.991 multiplied by 10 to the power 6, divided by my theoretical yield that I should have obtained if I have perfect conditions, would be multiplied by 100. This would be equal to 88.4%. This means my yield, percent yield, is equal to 88.4%. Thank you and goodbye.